Hello guys, I'm back with another coding interview questions, which is string anagrams. So given a string and a pattern, find all anagrams of the pattern in the given string. Anagram is actually permutations of a string. For example, ABC has following 6 anagrams. Right. So it's the same characters but in different order. Write a function to return a list of starting indices of the anagrams of the pattern in a given string. So let's take a look at an example. Alright, so whoops, wait a minute. Okay, let's delete this. Okay, so we're given a string, right? Our string has a total of 7 characters, right? So we need to return a list of starting indices of anagrams, right? So what are the anagrams of this pattern ABC? It could be one of these cases. So as you can see here, ABB. So our anagram uh, must be has the same number of characters, right? Firstly, as a pattern, it has 3 characters. So our anagram will also have 3 characters. So probably here, if we go for a brute force solutions, we're gonna check all the windows that has 3 characters, let's say. So this one, ABB, it is not this. It's not an anagram. BBC, go for BBC, and BCA. Oh, BCA, it's actually here. It's so we have one. BCA is one anagram starting at index 2 here. So our input array include index 2 here. Okay, so the next window side 3, which is CAB, which is also anagram, and finally ABC is of course another anagram. So we have total of 3 anagram. So for this kind of problem where you need to check different windows, if the window is if the window satisfies with some constraints, then probably think of using sliding window, because windows is represent for a consecutive substrings, right? So let's see how I want to use a sliding window to solve this problem. So let's say for each window we need to, how can we check if the current window is one of the anagram here. So actually what we care what we do care here is not the pattern itself, but the characters and its frequency, right? So as you can see, even in different order, but it is the same. It share the same characters with the same frequency. In this case, our pattern is just uh, can be represented as a map, right? Where key is a characters and value is a frequency. So A here is 1, B is 1, B is 1, and C is 1 as well. So our goals is to, for each window, we don't care about the exact match, but we care about is this window match this character with the same frequencies, right? Then, if that is the case, when I have one match, right, one uh, anagram. All right, so so here is the the thing that wanna constantly look at. Mm, as we uh, uh, as we uh, as we slide a window, right? Uh, Actually, there are two ways here. Is that we could store the current window in another map, right? So as we slide a window, we're gonna build a current map, right? And we constantly look up into the, let's say, the destination map, right? If it match or not. That's one way, but a better way uh, might be using this uh, this destination map, let's say, and every time we found a character that um, that is contained, that is included in this map, when uh, decrement the frequency in this map by 1, and when all the characters has a frequency of 0, it means mm, we have found a anagram, right? So let's think the frequency now is actually uh, the number of character left to be matched, right? So now we need to find 1A, 1B, and 1C. So let's start sliding a window. So window is just 2 pointers, left and right, and initially it will start with we're gonna start both pointers at the first character here, right? So okay, we'll start looking at the current character, which is A. Is A in the pattern here, pattern map here? Yes, we have 1A. So I will uh, because it's a match, so I decrement its frequency by 1. So now A is 1, means uh, we have uh, we don't have to find another A, right? We're done with this A now. We need 1B and 1C. Okay, so uh, our window now is only 1 characters. And in order to match with this, in order to be an anagram of this pattern, means no, this one instead, means it would be at least the same size, which is 3 characters. We have only 1 character now, so probably the next step would be to extend our window. Now the newly character that is added to the window is B, so we check B in our pattern map. So there's one B, right? So here we found I'm gonna decrement the frequency here by 1. So now we're done with A and B. It would be great if we have one more C in order to find a uh, anagram, right? But actually here, if we slide the window one more step, it will be um, it not C, but instead it's another B, right? So in this case, the frequency of B will be -1. So when it become -1, it means we have more than we need, right? If it's positive, it means that if it's 1 here, it means we have one C to be one C more to be found, but it's -1. So with this current situations, current state, then we have only one match, right? So as you can see, and the current window now is of size 3, which is the size of the pattern, right? And obviously it's not a anagram. An anagram, for an anagram, as we discussed, it should be A0, B0, and C0. Okay, so now it reached the size of the pattern and it's not an anagram. What should I do next? Probably not extend the window. Extend the window will not have us an anagram, right? An anagram is only outside of the pattern, and now we we reach size 3. So next step would probably to shrink it down. Okay, we have 1A out. We have 1A out, right? So 1A out, it means that I need to put the A back here, right? So A now is 1. It means there's 1A. We need to find 1A. Okay. Now the size of the current window is 2, which is less than the pattern. So next step would be to extend. Okay, C. Okay, C is in this map. So I will decrement it by 0, by 1, sorry. So now it's 0. So we're done with C. But obviously, the current window is not an anagram because uh, we still have key, we still have characters that is not that is not 0, right? Which is A and B. Okay. So as you can see, as we as we go on, we probably need a variable here, which is number of match, current match, let's say, right? In this situation, I have one match, right, which is the C character here. When it reaches 0, so now our window is of size 3 and it's not an anagram. We just do nothing here. So next step would be shrink the window down. B, this B is out. It means I need to increment this by 1. Sorry, so minus 1 plus 1 is 0. Okay, so now we have 2 match here. We need one more A to be an anagram. So after B reaches 0, I will increment the current match to 2. We need 3 match, right? So now this is side 2, so let's expand it. Now the new character is A. We have one A here, so I can update it to 0. So when it reaches 0, it means the current match will increment by 1. So we have 3 match now, which means the current window is an anagram. So I will store it in the result array, the index of the let's say the left pointer, which is in this case 0, 1, 2. Okay, we have 2. So now our window is of size the pattern, same size as the pattern, so we consider to shrink it down, right? So B is out mean I need to bring it back here. So now it is of size 2 now. I will consider another expand. Okay, C, the new character is B, right? So again, I will update this one to 0. And we have 3 match now, so I will add the index of C, which is in this case 3. Okay, again, our window is of size 3. I consider shrink it down, A and B. So after shrinking down, C is out mean I need to bring it back here. C is 1. Okay. So the size of the window is 2. Consider expanding it. C. New character is C. So I will again bring it to 0 because it's a match. So now again we have 3 match. So adding the index of A. So we have the final result here. Actually, we're not done here yet because we again shrinking it down when it reaches size 3, and here we eventually go out of the array boundary. So we're done here. Here's the result. So that's pretty much it about this problem. Let's turn the logic into code. Okay, what do we need here? We need a map, right? Let's say it's a pattern map, which is all the characters in the pattern and map it with frequency, right? So probably the first thing here is to build a map. So we build a map just by looping through all the character. So I'm going to use a for loop here, let character of string, and if the character not in the string, no, not in the pattern map now, I will initialize it with 0, right? Then after that, uh, update the frequency by 1. Okay. Next step. Next step, probably sliding the window. Slide our window. So window is just 2 pointer, left pointer. Let's say window start, which is 0, and right pointer will be in a loop. Let window end. Uh, window end also start at 0, and as long as the window end is still less than the string length, we want to go ahead. We want to get into this loop. Okay, at the beginning of each iterations, assuming I am expanding our window to the window end at the window end positions. So the new character here, let's say the current characters, is actually the characters at window end index, right? So now I will probably want to check that if this character is exists, if this character exists in the pattern or not, right? If how do I check it here? If the current characters is in the pattern, right? Then as we go to manually, if it's a match, if the new character is a match, then I want to update the, let's say, characters lab to be matched. Here is an, let's say this pattern map is actually number of characters left to be matched. So because it's a match, we found a match. It means number character left to be matched will be decremented by 1. So pattern map of current characters, I will decrement its values by 1, right? And as we discussed, we probably need a number of match. Initially it's 0, we have no match at the beginning, but as we're sliding a window, chances are when a frequency of the current characters reaches 0, it means we're done with that character and we have one more match. So if after this is updated and I do have a and the frequency of this character reaches 0, then I'm going to increment my match by 1. Update it by 1. It could be the case that it will go from 0 to -1, right? As we do the subtraction here. So if else it should be else if the pattern map of the current character is equal to -1, it means we are going from match to no match, right? we're going from 0 to -1. So I should decrement the number of match by 1 here instead. Okay, so what should we do next here? So with this kind of update, it's possible that here it could be number of match. When number of match equal to, let's say, is actually number of keys of this map, right? We have 3 characters here, right? And we need all characters, we expect all characters frequency which is 0. So we need a total of 3 match, right? So here I will check if number of match now equal to number of keys of object pattern map. If it's equal, we have all the match, and it is now a the current window is a anagram, right? So I will consider update our, let's say, the result, right? So I will push the left character of the window, which is in this case the window start, into this array, and finally when we're done, we'll return the result. Okay, so one last thing here, that we don't want our window is more than the size of the pattern, right? There will be no way there's an anagram. Our anagram should have the same size of the pattern, right? So if our window size is equal to let's say pattern dot length, then we don't have a window size yet. Window size could be calculated by window left on any window right. It would be window start and window end. Window end minus window start plus 1, right? So when the window size is of this pattern, we don't want to expand furthermore. If we when it reaches the pattern size and we go to the next iterations, it will expand the window. So here, before we extend our window by 1, here we will shrink it down by 1, right? So that the next step, we will have a window of size pattern, right? A pattern size. All right. So here, shrink it down. How to shrink it down? Shrink down window is just by increment the window start, right? But before increment the window start, I probably need to save the first character of the window, right? We need to update. We must update the pattern map. Window, because this is out, so we must put it back to the pattern map. Window, let's say first character is string at window start now. Before we update it here, we must save it first, right? So we only want to update the pattern map if the first character is in pattern, right? If the first character is in pattern map, then it means we need to put it back to our pattern map, right? First character plus plus. It could be the case that by updating this one, we could it could lead to number match being updated as well. So one way to check it is that before it is updated here, I will check the current character let we match. If it currently is 0 and down here we increment by 1, it means we're gonna lose one match, right? So in that case, number of match would be mine decrement by 1. Um, but another case is that the pattern match first character is -1. So here it currently -1 and down here it increment by 1. So it goes from -1 to 0. So it means that we have one more match. If that is the case, alright. Else if instead. Okay, let's run a test. Oops. We are failing test. What is wrong here? Object key of this pattern map. Pattern map character. Oh no no no. Character of this machine. If character is not in the pattern map, we when initialize its frequency by 0, then update it by 1 as well. Okay, look good. Okay, we have result array with window start with number match. So window end we start from 0 all the way to the end. Current character will be the character at the window end. Looks good. And if the current character is in the pattern, alright. Then I'm gonna update this. Right. Here is actually number of character let me match. Okay, so if after updated it reaches 0, we have one more match. But after updated, it go down to -1. We have one less match. Looks good. And number match equal to pattern match. Number keys here, right? We need to match exactly this number key. Then result push what start index here. I don't know what is wrong here. Search for P cannot use in operator. Cannot use in operator. What's wrong here? Can I do it in JavaScript? Let's say A in ABC. No, I cannot do it. So probably here we need to check the pattern map instead. Right. So let's say we have A1. So probably A will be in. No. Let's name it let's say x, right? So a in x, yes, but b in x is false, right? So here should check against the pattern map instead, and here also pattern map. Sorry, it was a silly mistake. Okay, another. All right, so it's not sure what's wrong here. We need to match it. Okay, we need to check it here. The first character. Okay, at Windows start. Then I will increment Windows start. If the characters is in, I consider updated. If the current values is 0, it means down here it will go up to 1. So we go from 0 to 1. It means I need to one less match, right? But it here it is right now -1. We go from -1 to 0, so we have one more match. It looks totally correct to me right now. What can be wrong here? Let's put this task and try to debug it with no. Okay, get inside. Let's go right here. We have 2a. We have no, not string but pattern instead. Need to build a map out of the pattern. Okay, it works. So that is it for this problem. Thanks for watching. See you in the next video.